Hi there everyone, welcome back to my YouTube channel, and if you're watching this on my Facebook page, then a warm welcome back to all my amazing and spectacular viewers back on my Facebook page. So I just want to start by saying I'm uploading a video after a long time, and that's because I got very busy, and now that I am free and now that I have time, I'm back on uploading videos for you guys. And this time we're going to be continuing off from biological molecules. We were done with carbohydrates, but let me tell you that this is AS level, it's not O level, so please be mindful of that. Well, we don't have the chapter biological molecules, it's known as nutrients, but here in AS we call it biological molecules. So we're continuing from carbohydrates. We were done with carbohydrates, now we're going to start with lipids, then we have proteins, and after proteins we have water, and then we're done. Alright, that's it. And this chapter is big, has a lot of details, so bear with me, and we're going to do our best to complete this off by the end of the video. Okay, so now let's start with lipids. Now let me give you this basic introduction of lipids, a general idea. Now you all have been studying lipids from your IGCSEs or O levels, nothing new about that, but let me just do a little bit of a recap for your ease. Okay, so first things first, they're organic molecules. They're composed of 3 elements, right? You've been studying this from O levels and IGCSEs, nothing new about that. If not, I'm going to cover it for you right now. So you have hydrogen, you have carbon, and you have oxygen, right? Hydrogen, carbon, and oxygen right here. I think I made a mistake and I wrote out hydrogen again, sorry about that. So they contain hydrogen, carbon, and oxygen, right? Now one other important thing to understand here is that the ratio of oxygen to hydrogen is low. In other words, the amount of oxygen is very low. Now in carbohydrates, the amount of hydrogen is more than oxygen in the ratio of 2:1. That is a water molecule, and that's how we identify a carbohydrate. But here the oxygen amount is less, so that's how you can differentiate lipids from carbohydrates, because they both contain the same 3 elements, but from the composition of oxygen you can tell that this here is a lipid. Okay, and lipids do not have a fixed composition. Like we have this general formula of carbohydrates, right? Lipids lack a general formula due to not having a fixed composition. For instance, the amount of the 3 elements can vary in different types of lipids, so that's why there is no general formula. Now they contain more energy. Just want to emphasize on this point, it is very important. They give you an MCQ, sometimes they may give you a question in paper 2, and then you may have to answer. That is, they contain more energy as compared to carbohydrates. Okay, when you compare this to carbohydrates, they contain more energy. However, lipids are more complex and carbohydrates are more simple. Now it's pretty logical that if you want to break down lipids is gonna take more time to break down. Therefore, athletes actually prefer to eat carbohydrates. Though they may contain less energy, they're broken down faster and they supply you with energy faster. So the next time you want energy fast, just have some carbohydrates. Your body will break it down fast and supply you with the energy you need through respiration. Lipids, however, do provide more energy, like about 39 kilojoules of energy, but then again they take time to break down. Carbohydrates provide about 17 kilojoules of energy. Okay, and yeah, this is what I just said. This is why athletes prefer carbohydrates. You do get a question on this in the O levels or IGCSEs. Okay, so there's lipids are soluble in organic solvents. Organic solvents means like ethanol, chloroform, right? All those organic liquids, they're soluble in those organic liquids but insoluble in pure water. Now that is a bit of chemistry that is not required here. Just need to know that they're soluble and insoluble. Yes, this is extra, right? I'm just giving this for the sake of knowledge, that water has hydrogen bonding, and for a molecule to dissolve in water, they must have both the charges, that is positively charged atom and as well as a negatively charged atom, and then they are attracted to the water molecules and the bond is broken. We will discuss that in the water section, so don't worry about that. Okay, so the simplest version is composed of a glycerol molecule. When lipids are digested or broken down, we know that in all those in IGCSEs they're broken down through emulsification, but then again this is AS, we're not discussing that. They're converted into a glycerol molecule and a number of fatty acid chains attached to the glycerol, and then they are absorbed in the lymphatic vessel. Okay, so this is what a lipid in its simplest version looks like. This here is a glycerol molecule to which 1, 2, 3 or maybe more fatty acid chains are attached, and this is here line is a bond. We call this an ester bond, and I will explain this in an upcoming slide. Okay, now let's get to the real A levels here. Now this is brand new and totally unfamiliar, but don't worry, we're going to cover all of that. Now let's talk about the chemical composition, which involves a little bit of an organic chemistry that I will try to make as simple as possible if you are weak in it, because don't worry, not much of organic chemistry is required in A level bio. So fatty acid, let's talk about the chain that is attached to the glycerol molecule. So our main focus is on your fatty acid. Here is the fatty acid. Okay, so these are some chains. Now we're going to study what these chains are made up of. They're acidic in nature, just from the name you can tell. It's an acid in nature. Why? Because they have a carboxylic acid group. Now then again, for those whose chemistry may be a bit weak, I'm sure everyone must know this. This here is your carbonyl compound. That is a double bond, carbon having a double bond with an oxygen atom present in aldehydes, ketones, and carboxylic acids, and in esters. Remember that this carbonyl group is found in esters and carboxylic acid. Okay, and then you have an OH group attached. Okay, so this here is your carboxylic acid, COOH, and then here 1, 2, 3, 4. Carbon has 4 bonds. Something else may be attached here. Okay, but then again, just to give you a basic idea. Okay, so then the fatty acid consists of an acidic head, which is a COOH that has a hydrocarbon chain. Now let me explain. This might seem a bit unfamiliar. So think of it as like this. This here is the glycerol molecule. Now we know that some fatty acid chains are attached to the glycerol molecule. Let's talk about the fatty acid chains in detail. For example, this here is the acidic head, and this here is the hydrocarbon chain that I am drawing. This is the skeletal formula I'm drawing. Sorry if it's rough, right? This is another acidic head. Then goes the hydrocarbon chain like that. Hydrocarbon is basically carbon and hydrogen atoms, right? And this is the acidic head. That is mainly the carboxylic group. Now let's look at it at a much clearer way. Now remember the hydrocarbon chain can be shown like this, okay? Which is also a skeletal formula. The corners represent your number of carbon atoms, like 1 carbon atom, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so there are 9 carbon, and then you can draw a straight chain and fulfill the valency by drawing the hydrogen atoms. Okay, that's very simple. Okay, so let me explain it again. Let's grab blue. Okay guys, this whole thing here is a fatty acid chain. The glycerol molecule is not involved here. Okay, some people confuse the carboxylic head or the group or the acidic head with the glycerol molecule. No, the acidic head is attached to the glycerol molecule, and then the hydrocarbon chain is attached to the acidic head, right? So this section here is the carboxylic acid group, which is also known as the acidic head, therefore the COOH group. Okay, now this is one thing you need to understand. Now this here and this here is your hydrocarbon chain. Yeah. So the hydrocarbon means any compound or molecule consisting of just carbon and hydrogen only. That's it. And this is a big chain of it. You can see here they've drawn it like this. They may also draw it like this, as I just showed you here. You can have a look at it here once more, like this. Okay, but they've drawn it openly as a structural formula, as a discrete formula. So that's much better in my opinion for your understanding. Okay, so that's the one thing to understand. Now there are 2 types of fatty acids. As you can see, it's in blue here. That is saturated and unsaturated. Okay, unsaturated means having a carbon double bond, and saturated means having no carbon double bond. It's as simple as that. There's no rocket science here. You can see here no carbon double bond at all, and this actually implies that this here can contain maximum number of hydrogen atoms. If you look over here, this is the hydrocarbon chain here, and that's the acidic head. this here is your carbon double bond over here, and then over here we're talking about unsaturated. Okay, so whenever you see an carbon double bond in the hydrocarbon chain of the fatty acid, that is unsaturated fatty acid. Now in chapter 4 of AS level, we will study how this impacts the properties of your cell membrane. I don't want to get into that. That's a new thing to understand, involves new topics and stuff. Let's put our focus here for now. Okay, so so let's talk about the glycerol molecule. This is very important. Okay, this is a very important point. I'm gonna highlight this for you so that you know that this is actually quite important. The glycerol is an alcohol in nature. A glycerol is an alcohol in nature, and remember that. Okay, so that means that the fatty acid chains which are acidic are attached to an alcohol when we talk about lipids. Fatty acid has a hydrophobic chain or non-polar hydrophobic chain. Now I just want to go back to explain what I mean by this. Do you see this chain here of hydrocarbons? This is hydrophobic, which means it is non-polar. Now what does hydrophobic or non-polar mean? Hydrophobic means water hating, means it repels away from water, and hydrophilic means water loving, which means anything that's hydrophilic will dissolve in water, and anything that's hydrophobic does not dissolve in water. Therefore lipids are insoluble in water. Okay, so remember that you can refer to them as non-polar, or you can refer to them as hydrophobic. If you want to call them non-polar, that basically means two elements that do not have a dipole, which means no opposite charges, right? And having no charges means they have the same electronegativity, and that's chemistry, right? Let's talk about some terminologies. For instance, the first terminology that I want to talk about is monounsaturated and polyunsaturated. Okay, so the word mono means one carbon double bond. So monounsaturated fatty acids have one carbon double bond in their hydrocarbon chains, whereas polyunsaturated fatty acids have many, like more than 2-3 carbon double bonds in their hydrocarbon chains or in the fatty acids. Okay, so just remember that. And the more the number of carbon double bond, the least the number of hydrogen atoms, and expect there to be about 15 to 17 carbon atoms in both unsaturated and polyunsaturated. Remember that a carbon double bond is weak, so polyunsaturated have a lower melting and boiling point because carbon double bonds are weaker and single bonds are stronger. Now due to that, saturated fatty acids or lipids containing a saturated fatty acids are solids at room temperature and pressure, and lipids containing an unsaturated fatty acids are liquids at room temperature and pressure. Let's talk about butter. Butter is a lipid and it's saturated, that's why it's solid. If you talk about olive oil, it's also a lipid, but it is unsaturated. Why? Because it is liquid at room temperature and pressure, so this is something extra. So for example, animal fats are usually saturated, and plant lipids are usually unsaturated, like olive oil is derived from a plant. Okay, so remember that. Now this is one important chemical reaction here known as esterification. You study this in AS chemistry, that is your organic chemistry, in which an alcohol and an acid combine together to form an ester. They combine via a condensation reaction. That is, just to recap, we have done this previously. When two simple molecules combine together to form a complex molecule, that is known as condensation. And in condensation reaction, a water molecule is always formed. Okay, and yeah, that's what you need to understand. And you know, whenever there is condensation happening, you can also hydrolyze the formed compound back into the substituent reactants. Okay, therefore giving rise to a reversible reaction, and a reversible reaction is shown by this, right? This is chemistry again. No need to get into much detail here because we are doing biology here. Everything that is required of chemistry level is being covered here because I'm trying to explain it from the basics for the ease of every student. Okay, so that's just as I explained, alcohol and acid combine together to form an ester. You can hydrolyze an ester to form back the alcohol and acid in the reverse reaction. Now this shows the forward reaction, and this shows the reverse or the backwards reaction. During esterification, an ester bond forms between the acid and alcohol. And when the acid and alcohol combine together, that ester bond, that is CO, holds both of them together. Now, why is esterification being discussed here? What is the role being played here? That's easy. We're showing how lipids are formed, right? A lipid is an ester. So when an alcohol, that is your glycerol. Remember I said that a glycerol is an alcohol in nature? So that's what I mean, that your glycerol, which is an alcohol, combines with your acid, that is your fatty acid, to form a lipid, that is an ester, right? Now we'll look into that in much more detail. Okay, so continuing. A glycerol molecule is an alcohol, as we discussed earlier. Now let's discuss the chemical composition of a glycerol molecule. It has 3 OH groups. Now OH is a functional group of alcohols, and this here has an OH group, therefore showing that it's an alcohol. Now let me talk about the display formula of this here. Now this here is your glycerol formula, as you can see here. Please observe this as I explain. Now it has 3 carbon atoms, to which each of them contains an OH group that you can see here, and it is unbranched. And to fulfill the valency, the remaining bonds are given a hydrogen atom. So this is a glycerol molecule, fairly easy, nothing difficult or complex about it. Okay, now let's understand the 3 fatty acid chains. Now I'm going to use a different colored pen to understand, for your understanding. Now I'm going to circle the acidic head. This here is the acidic head. Oops, sorry for that weird circle or whatever that is. Another acidic head, and this is another acidic head, that is a COOH. Notice the carbonyl compound. Now this R here, this R is your hydrocarbon chain. Now it would take a lot of space to draw it, so this is shown by an R to make you understand that this is your hydrocarbon chain. So you can show your hydrocarbon chain within R, or you can also make it like this, right? Both are fine, whatever is easy for you. Or you can just write the full thing down. Normally they don't write the full thing down because it takes a lot of time and it occupies a lot of space. Okay, right. So during esterification, the glycerol, which is an alcohol, combines with the fatty acid, which is an acid. The glycerol combines with the fatty acid. This glycerol here is an alcohol, and this fatty acid is the acid, therefore giving rise to an esterification reaction to form an ester, which is known as the triglyceride, and a water molecule is also formed because this is a condensation reaction. Let me explain this again. Glycerol, which is an alcohol, reacts with fatty acids, which is an acid. An esterification occurs in which an ester is formed. This is an ester. One second. This here is an ester, which is a lipid, and the name of that lipid is a triglyceride. Okay, triglyceride. And a water molecule is also formed because this here is a condensation reaction, just like I explained. So remember, whenever there's a condensation reaction, always expect there to be a water molecule formed. This here is your water molecule. Okay, remember that. And yeah, so whenever in exam question they give you that a triglyceride is being formed, a glycerol has to react with 3 fatty acid chains. This is a special unique feature of this reaction. Okay, or else if you make it 2 fatty acid chains or 5 fatty acid chains, you can give rise to another type of ester which may have another name. So in our course we have triglycerides and phospholipids. We will discuss phospholipids in a bit, but for now we're discussing triglycerides, and remember 3 fatty acid chains, not more than that. Okay, so triglyceride consists of 3 fatty acid chains attached to a glycerol molecule. So when you look at this triglyceride molecule here, which is an ester or a lipid, this guy here has 3 fatty acid chains attached to its glycerol molecule. I'm going to rub this out. If you guys want to just understand this again, you can rewind the video, right? Sorry, you can just reverse it and have a look at it again. Just give me a second, because I need to explain the structure. Okay, now what do I mean when I say that 3 fatty acid chains attached to one glycerol molecule? Let's first identify the glycerol molecule. Let's use, right, okay. Now this full thing here is your glycerol molecule right here. Remember that? Now let me show you the 3 fatty acid chains that I'm talking about. I'm going to highlight it for you. Okay, This here is the fatty acid. Okay, it's too light. Let's grab another colored pen. Yeah, red is fine. This here is the hydrocarbon chain. Okay, let me show you the acidic head. Okay, this here, let's see double. One second. Okay, this here is the acidic head. The OH is shown with the R, therefore not shown here, and this is the acidic head. And then this here is your hydrocarbon chain, and hydrocarbon chain. So what I mean here is that this here is the glycerol molecule, and this here is the fatty acid, and this O here in the middle is showing an ester bond. See how they're connecting the glycerol with the fatty acid. Okay, I'm going to explain this again because it got a bit unclear, so let's discuss this again. Okay, so this here is a triglyceride, and let's first identify the glycerol molecule. Okay, first of all, this here is the ester bond. The O here always shows the ester bond. Remember that, okay? Ester bond, okay? And this section here is your glycerol. The entire here is a glycerol molecule, okay? They've just shown the chemical composition, okay? And then this part here is the long fatty acid chain, that's one. Then this is the second one. And then this is the third one, okay? So written out in a short manner. And then you can identify the acidic head of the fatty acid chain from the COOH. Now they haven't shown the COOH and explained why. You can see here, now this here is the acidic head, and then this is the OH. Now whenever esterification happens, the OH from the glycerol and the COOH from the fatty acid react, and water molecule is removed. For example, H is removed from the acidic head. That's why H is not shown here. Okay, sorry, I misguided you. H is not shown here, and the OH is removed from the glycerol. This is a minus H2O reaction, therefore calling it a condensation reaction, and that's why a water molecule is formed at the end. It's removed and removed, and then you can just combine it. That's why the C and O are combined, giving rise to the triglyceride molecule. Now the last thing about triglyceride is to understand some of the uses, some rules. For example, they're good energy reserves. The carbon and hydrogen bond are rich, and they supply a lot of energy when you break that bond. They contain 1,000 times more energy than carbohydrates. Yes, we discussed that lipids have more energy and triglycerides have even more. And basically the fat stored under the adipose tissue or in our bodies, that is under the skin or maybe in some of our organs, to prevent heat loss, or as an insulator, that is to keep our bodies warm, because it prevents the heat from escaping. It traps the heat in our bodies. So that's why it is used as an insulator in our bodies. And what do I say what does this mean when I say metabolic source of water? So let's understand this first. It's very simple and basic. If you're running low on maybe water, not energy, water. You need water, your body is lacking water. So what happens is that the triglycerides are oxidized. Respiration occurs. And in urgent need, water molecule is produced as a waste product of respiration to fulfill the demand of lack of water. So the next time if your body is lacking water, the triglycerides will undergo oxidation, that is respiration, producing water. But that water molecule will not be a waste because it will be used by your body due to having lack of water. Yeah, the carbon dioxide is obviously going to be waste. It's going to be expelled from your body. Okay guys, now we've covered your triglycerides. And now we have phospholipids. And phospholipids is a bit lengthy, a bit complicated, so let's keep it till here. Just have your time, revise this. And if you have any questions, let me know in the comment section down below. Any requests, let me know in the comment section down below, and I will do my very best to fulfill those needs. And I have an announcement to make. We're going to be improving our video making in the next couple of months. So basically we'll be doing making more better videos for you, and I'll start making passport videos too. I haven't made any yet on AS level, and I'll be making on O level and GCSE. Stay tuned for that. Subscribe to my YouTube channel, like and comment down below, like and follow my Facebook page, share this around because I'm making free content, free educational content just for you guys. So be sure to subscribe, like, follow and share, and as always, keep learning. See you next week.